Very good morning. Myself is Dr. Timothy Jose, Technical Service Section, Tramco Titanium Products Limited, Thiruvananthapuram, Kerala. This is the year we are celebrating the anniversary of potential production of TiO2 based pigment bisulfate route. So the topic TiO2 pigment industry challenges and opportunities in Indian context. First of all, I will present a brief history of development of TiO2 pigment industry from 1916 to 2016. Then the present scenario, challenges and opportunities. Finally, the technologies for tomorrow. Titanium element was discovered in the 18th century, but the potential use of TiO2 was really started in the beginning of the 20th century. 1916, there was two companies. One was Titanium Pigment Company in New York. Another company, Titan Company in Norway, was established and started producing TiO2 based pigment. In 1919, the annual output reached 1000 metric ton, but it was 25% TiO2 and 75% barium sulfate. In this year only, these two companies are exchanging their patents and technologies for the production of TiO2 pigment. In 1920, National Lead Company taken over the Titanium Pigment Company and increased the production capacity. In 1923, almost pure TiO2 pigment, that means 96 to 99% TiO2 was produced by the hydrolysis of TiO4, which is produced from the ilmenite. In 1930, the Mecklenburg method for axial nuclei was tested and started producing TiO2 pigment which better quality by improving the hydrolyzation process. In Asia, in 1935, Japan started producing TiO2 pigment in 30s. And in 1939, rutile grade pigment was first officially launched in the market by a Czech company. And in 1940s, the National Lead Company and DuPont become main producers of TiO2 pigment, and the anatics start replacing by the rutile pigment because of because of its better hiding power. In 1948, DuPont started studying the chlorination process in industrial scale. When you are looking to India, the first TiO2 facility was there at Thiruvananthapuram. It was Travancore Titanium Products Limited. It was incorporated in 1946 December 18th and started construction in May 1949. The managing director was Dr. A.L. Robert and chief engineer was Mr. A.K. Makhallam. And in 1951 it started production with the installed capacity of 5 tons per day. That means 1,500 tons, metric tons per annum. And it started marketing in November 1951. In 1950s, the environmental protection demanded a lot of investment because of the effluent treatment from the sulfate process. And people are thinking about new methods to reduce the effluent. One Canadian company, Quebec Iron and Titanium Corporation, started producing titanium slag in 1951. 1956, DuPont started producing TiO2 pigment by chloride process, and 1957, good quality, high quality rutile pigment from the chloride route is widely used in the United States. It had a good hiding power, that means almost 7% higher hiding power than the conventional rutile which is produced from the sulfate route. In 1960s, actually the surface treatment technologies got developed and the silica encapsulation improved the weather resistance of the pigment. The photocatalytic activity of the anodized pigment or the rutile pigment got reduced by the surface treatment, and the sulfate process started replacing with the chloride process. There was a healthy competition between sulfate process and chloride process this time, and 1970 the total production of TiO2 pigment is reached 16 lakhs tons, and 5 or 6 companies, DuPont, Dioxide, SCM, Chimera, Kerr and Mackay, accounted for almost 70% of the total production of TiO2 worldwide. In 1980s, the chloride process is started in India. In 1979, the chloride plant is put over Kollam, Kerala Minerals and Metals Limited. The know-how was provided by Karmaki Chemical Corporation USA, and it is commissioned in 1984 with the installed capacity of 40,000 metric tons per annum. And 2011 it is also started producing titanium sponge manufacture. 1990 was not a good time for TiO2 manufacturers all over the world because of the overcapacity, weak demand and low price, etc. But in India, there was two companies, two private establishment was come in India. One was Kilburn Chemical Limited, was in November 1994. Almost same time, another company in Kalyan, West Bengal is installed capacity of 2,400 metric tons per annum. In 2011, the Kilburn Chemical Limited is taken over by VV Pigments. Now the production capacity of this facility is 14,500 metric tons per annum. Today, the total production of TiO2 all over the world is almost 6 million tons. China is producing almost 35% of the global share, and India is the one of the fastest growing TiO2 market, and India consuming almost 5% of the world production of TiO2. India is also producing approximately 60,000 metric tons per annum. It is only a 20% of the total demand in India. What are the challenges what you are facing at present? One is the price slash because of the overcapacity in the worldwide. Prices come down, not only in India, everywhere. And recession in the worldwide, weakness in the Indian manufacturing sector. Specialized product is needed for the industry that we could not produce. Low priced Chinese pigment and replacement of TiO2 by another pigment with the price increase of TiO2, that also happening in India. Towards the TiO2 consumption and production forecast in 2008 to 13, and it has come true actually. The global supply and global demand, you can see that it was higher in 2010. Demand was higher compared to the supply, but in 2011 it is closed, and 2013 there was a wide gap between the global supply and global demand. So of course supply is more compared to demand and the prices go down. This is actually expected price in 2016, but as we know that it was not happened, it is just come down. When you are comparing India and China, you just see that 1920 and 2015, India is produced 24,000 metric tons of TiO2 in 1980, and China is produced only 2,000 metric tons. In 2015, India increased the production from 24,000 to 76,000 metric ton, almost 3 times. But China is produced increased the production on 2,000 metric tons to 21 lakhs metric tons. Traditional method sulfuric acid process, almost 58 companies are working in China according to China's population resources and environment 2011 reports. A number of companies are under construction, and again they are planning to increase the put new plant in China. Indian coating market have a good future actually, so that it is improving like nothing. And in 2020 it is expecting approximately 60,000 crores of business. Indian decorative market, there are mainly 4 to 5 players. One is Asian Paints, that is the biggest player in the decorative paint sector. Almost 52% of the total paint sold in India is manufactured by the Asian Paints. Then Berger Paints, almost 11%. Akzo Nobel, Kansai, Shalimar are the other paint manufacturers. But the real problems in India, we got a good demand, we got a good source of ilmenite, good deposit, high grade ilmenite, particularly in India, but we are not able to produce TiO2. What may be the reason? One is the bureaucratic hassles, high power tariff, inadequate infrastructure, expensive logistic, and land allotment. But few companies were actually interested to invest in India. One is by Tata, almost 25 million rupees project it was, but it was not come true. Another was in Kolkata based Saraf agencies, but still it is the discussion. From here itself we can assume there are lot of opportunities there for the TiO2 industry, not only due to the good demand. So you know that the TiO2 demand was GDP is always a straight line. You can see that demand, increasing GDP, yes, of course TiO2 consumption also increasing. So the developing like country like India have good opportunity. You can see that world resources of ilmenite and rutile. India got 85,000 into three zeros. Yeah, a good demand is there. Sorry, good serve is there in India of TiO2 of ilmenite, and of course for the retail, actual retail. And India is producing very less, as I presented earlier. India is producing only 21% of its total consumption. The shortage of 2 lakh tons of TiO2 we are importing from other countries. And per capita consumption in the developed countries, it is in America and all, it is United States, it is 4, in Australia it is 2.3, Japan it is 2. If the per capita consumption in India is increased from 0.3 to 0.5, it is opening a good demand of TiO2 in India. TiO2 is selling in India, not only in India, everywhere, not only as a pigment, in different grades it is now coming on the market. One is nano grade TiO2, high purity TiO2, food grade TiO2, pharma grade TiO2, fiber grade TiO2, cosmetic grade TiO2, catalytic grade TiO2, macro TiO2, transparent TiO2, doped TiO2, number of TiO2 composites. So according to the customer satisfaction or customer's requirement, we need to prepare the TiO2. And not only the technology, the hygienic conditions and certifications also need to sell the TiO2 to number of industries. What are the technologies for the future? Alter nanotechnology. Actually, I don't say production method for the manufacture of TiO2 pigment. They got a small pilot plant for the production of zinc, but it was not that much successful. Now it is not running, what I understand. This is also a digestion and extraction process. Another recently CTL technology, Canadian Titan Limited, is developed this technology, and the pilot plant is also put up. This is also a HCl digestion and solvent extraction of iron and titanium separately, and the precipitation of TiO2 from the solvent. And according to them, TiO2 and iron oxide both can be saleable, and the TiO2 pigment purity can reach up to 99.8%. According to these are the benefits. One is that high purity, second both anodized and rutile can be produced, No pressure vessels are needed. It's a continuous process, environmentally attractive, sellable byproduct. Process is flexible, safe for operation, reagent recycled, revenue from the byproducts. These are the benefits according to the CTL process. There are some demerits also. Still, the efficiency of the process can have to be proved, and different feedstock to be stabilized. These are the major challenges in front of CTL process. What are the future technologies? Of course, there may be a more engineered material can come instead of TiO2. It's possible to produce a material which have a high refractive index compared to TiO2, or is it possible to increase the refractive index using by engineering the material? Is it possible to produce low TiO2, low cost TiO2, produce low cost TiO2 pigment? More engineered material, as I told, it can be produced or not. Another one of the opportunities that sulfate process is the surface treatment can be done in the rotary in itself instead of separate wet treatment. Anyway, tomorrow is bright. You can expect that a finely engineered material can be produced, will become coming into the market very soon. Thank you for watching. Keep sharing.